What if we could reach up and turn down the sun's thermostat, cooling our entire world? This isn't science fiction. It's a real question scientists are asking as our planet heats up at an alarming rate. The idea: spray a fine mist of particles into the upper atmosphere to reflect sunlight and cool the Earth. A concept called solar geoengineering. Think of it as sunglasses for the planet. This radical proposal forces us to confront our role as stewards of Earth and the limits of our technological wisdom. Are we ready for such a monumental step? The urgency is real. Global temperatures are rising, glaciers are melting, and extreme weather is becoming the norm. The main culprit is clear: greenhouse gases like carbon dioxide, trapping heat since the Industrial Revolution. Cutting emissions is the ultimate solution, but progress is slow. Solar geoengineering isn't a cure, it's a possible emergency brake, a temporary measure to buy time. It's a testament to human ingenuity, but also a stark reminder of the predicament we've created. We're now considering deliberate climate manipulation because our accidental actions have pushed us to the brink. This journey explores the science, risks, and ethical dilemmas of playing God with our planet. To grasp why solar geoengineering is even on the table, we must face the reality. Earth is running a fever. Over the past century, global temperatures have climbed faster than at any point in human history, driven by our cars, factories, and power plants. Carbon dioxide, once stable for millennia, has soared to levels not seen in hundreds of thousands of years. This greenhouse gas traps heat, thickening the atmospheric blanket and warming our world. The effects are everywhere: melting ice caps, rising seas, stronger hurricanes, droughts, and wildfires. Coral reefs are dying, ecosystems are unraveling, and the web of life is under strain. The main solutions, renewable energy, efficiency, and carbon capture, require massive, slow, global cooperation. But the clock is ticking, and many fear we're not moving fast enough. That's why some scientists are asking, if we can't fix the greenhouse quickly, should we try to dim the sunlight instead? It's a desperate question, born of a desperate situation. Solar geoengineering is being considered not because it's ideal, but because the alternatives may not arrive in time. The stakes are nothing less than the future of our planet. The debate is no longer theoretical, it's urgent. How could we dim the sun? Nature has already shown us volcanic eruptions. When Mount Pinatubo erupted in 1991, it blasted sulfur dioxide into the stratosphere, forming a global haze of reflective particles. This volcanic sunscreen cooled the planet by about 0.5 degrees Celsius for over a year. The lessened particles in the stratosphere can scatter sunlight and lower global temperatures. This is the blueprint for stratospheric aerosol injection, or SAI, the most discussed form of solar geoengineering. Instead of a single eruption, fleets of high-altitude aircraft would release controlled amounts of particles, like sulfur dioxide or calcium carbonate, into the stratosphere. The goal: maintain a thin, persistent veil to offset some warming. We'd be creating a man-made, adjustable volcanic winter. It's elegant in concept, but the implications are profound and potentially terrifying. The question isn't just can we do it, but should we? Until recently, solar geoengineering was mostly theory and computer models. Harvard's ESCOPEX project aims to change that with a small, cautious, real-world experiment. Using a high-altitude balloon, scientists plan to release a tiny amount of calcium carbonate into the stratosphere, far less than a commercial jet emits in a minute. The goal isn't to cool the planet, but to gather crucial data. How do particles disperse, react, and reflect sunlight? Our models are only as good as the data behind them, and real-world tests are essential. Yet even this tiny experiment has sparked controversy. Critics fear it legitimizes a technology that could be misused, or that it's a slippery slope to full-scale deployment. The debate around SCOPEX reveals that the challenges are as much ethical and political as they are scientific. Even studying this technology forces us to ask, should we go down this path at all? Most of what we know about solar geoengineering comes from climate models, digital simulations of Earth's complex systems. By adding virtual aerosols to these models, scientists can test what-if scenarios. The results are striking. Models suggest that stratospheric aerosol injection could cool the planet by 1 to 2 degrees Celsius within a few years, enough to offset all warming since the Industrial Revolution. The cooling could be relatively uniform, even slowing polar ice melt and reducing some extreme weather. But models also warn of risks. They're simplified, and regional effects are hard to predict. Different models give different answers, and real-world chemistry is still uncertain. The message is clear: solar geoengineering could work, but it's a massive gamble with our only climate system. The digital world offers hope and a warning: we're still flying blind. Most climate solutions come with staggering price tags: trillions for renewables, efficiency, and carbon capture. Solar geoengineering, by contrast, is shockingly cheap. Estimates put the annual cost of a full-scale program at just $10 to $20 billion. That's less than the world spends on ice cream each year. This low cost is both tempting and dangerous. It means a single nation, or even a coalition of small countries, could afford to act alone, altering the global thermostat without international agreement. The risk of unilateral action and geopolitical conflict is real. The economics shift the debate from "can we afford it" to "should we risk it?" The barrier isn't money, it's ethics, risk, and governance. The risks of solar geoengineering are enormous. Changing sunlight could disrupt global weather patterns, shifting monsoons and threatening food and water supplies for billions. Our models can't predict these regional impacts with certainty. We'd be running a global experiment with no do-overs. There's also the threat of termination shock. If geoengineering stopped suddenly, rapid warming could devastate ecosystems and societies. The technology doesn't remove carbon, it only masks the problem, requiring decades or centuries of commitment. Most alarming, there's no international governance, no rules, no treaties, no oversight. Who decides if, when, or how to deploy it? What if one nation's solution is another's disaster? The potential for conflict is immense. The stakes, nothing less than the stability of our planet. Solar geoengineering sparks fierce debate about ethics, responsibility, and the future. Critics warn it's a moral hazard, a tempting shortcut that could undermine efforts to cut emissions, letting polluters off the hook. They argue we don't know enough to risk such a massive intervention, and that we should focus on reducing carbon. Supporters see it as a potential lifeline, a tool to buy time if climate change spirals out of control. They argue research is essential, so we're not forced to deploy it blindly in a crisis. It's not a replacement for emissions cuts, but a possible last resort. The debate is a choice between the known dangers of climate change and the unknown risks of planetary engineering. The stakes are existential. We stand at a crossroads, contemplating an intentional intervention in Earth's climate. Solar geoengineering offers hope, a fast-acting shield against catastrophic warming, but it's also fraught with peril, droughts, conflict, and technological dependence. The debate is about more than science. It's about values, risk, and the kind of future we want. Do we have the wisdom to wield such power responsibly? The conversation must be global, open, and honest. Should we keep this option on the table, or are some doors better left closed? The choice we make will echo for generations.